If you purchase the complete kit, you'll have the assembled PC board and 1, 2, 3, 4 NeoPixel quarter ring segments. The first thing you need to do is to solder all 4 of these together. It's not an easy thing to do necessarily, but masking tape is your friend, and I will show you that in just a second. I like to start by taping one of the segments down, putting a piece on the next one, very carefully lining them up here, and then what I'm going to do is move on to the other 2 and kind of jockey them back and forth a little bit until I end up with a good circle. So I've got a couple of them taped up, and this last one here is not quite lined up, so squeeze that in, jockey them around, and I may need to loosen this one up a little bit. Loosen this one up a little bit. Sometimes it takes me more than one try. I'm getting better at it though. You want this thing as close to a circle as you can possibly get. I've added extra tape. I find that it's most stable if I have about 3 pieces of masking tape per segment. Now you can see everything is all lined up. What we're going to do next is we have to bridge these things. So outside that's ground, and then data in, data out, and then plus 5 volts. So we'll bridge these 3, these 3, these 3, and up here this is going to be the start of the ring. So we are going to bridge the ground and the 5 volt on the outside, but we are not going to bridge the D in and D out. What we will do is we will solder a wire to the D in and solder that to the clock board. We aren't going to do that just yet, but when we are ready, right here, this is labeled AN4 or Neo pin. There's actually 2 little holes that you can use based on which is the most convenient. There's a set of 3 holes if you wanted to put a 0.1 inch header strip there, and you'd have the Neo pin plus and ground accessible. But what I do is I use this one out here, and the ground hole over here, and the plus 5 volt hole over here. That gives a little bit better stability once it's all put together. What I like to do is take pins from standard 0.1 inch headers, pull them out of the header, and then lay them across here to solder, and that gives a little bit more mechanical reinforcement in addition to the electrical connection. Some people just solder bridge it across. That works too, and you can also use a lighter weight wire. More important thing is to make sure that you have good solid connections and they aren't shorted between the 3 different types of pins. Here I have the completed ring. You can see there's 3 pins across there for the 3 connectors, 3 there, 3 there, and only 2 of the pins here. The ground and plus 5 are connected all the way through, and this wire here is only connected to the one side that's labeled D in or data in. Goes from the board to D in and then cycles all the way through the rest of them. Got my plus going to one of these little round pads marked plus on the NeoPixel ring. The negative going to one marked G. Really doesn't matter which of those pluses and G's that you use. I just put mine up at the top so that 12 o'clock will be up here. This is the completed ring from the other side. I've also placed a 1220 battery in there. A 1216 will also work, and possibly even a 1225. I have a couple of these headers soldered in. Normally you wouldn't have those, but I've done that because I'm prototyping and working with these ones. But this is the standard Arduino style or Atmega style programming header. And this one here allows me to connect up to NeoPixels without having it soldered together. So I've got the NeoPixel pin, plus, and ground. And now I have a standard, ordinary USB micro B power supply, which I always put upside down. Okay, and there we go. A little harder to see in the lighting, but you notice the hour marks are all in the PM pink. In the AM they'd be orange. You can change that if you want through standard Arduino programming. Got the hour hand on 3 and the minute hand on 46. So it is 3:46, about to turn to 3:47. There we go. The light sensor's right here, and what that does is it dims it for a dark room so that it won't blind you in the middle of the night, and brightens it when there's a bright sun. So, for example, shining a flashlight on it, you can see how bright the NeoPixels come. You can also adjust the brightness manually by pushing the button on the side there. User 1 goes up, user 2 over here goes down, and then the brightness will vary from the point at which you've adjusted it with those things. So here I dim that and it gets really dim. To set the clock, there's two ways to do that. First of all, if you hook this up to a computer and use the Arduino IDE, when you compile and load the software that came with this, if you press user 1 and hold it while you compile and upload, it will reset the clock to the time at which that software was compiled. So that only works when you're compiling it. That always keeps the time from when you compiled the code. That's the way the IDE is. You could program a little something on the PC to connect up to the RS-232, which comes through there, and program it that way, but I haven't done that. To set the time, I hit both of these buttons at the same time. Little yellow LED comes on to indicate that it's time setting mode. This button, user 2, moves me back. You notice when I crossed over midnight, that's hard to see because of the lighting, but those turn to orange. User 1 goes up an hour. Hit those two buttons again, and now I'm in setting the minute mode. Just like that. Hit them a third time, and it will go back into timekeeping mode and reset the seconds to 0. With the source code, which you can download, you can do an awful lot more with this. You could set alarms so the whole ring would flash at certain times. With the inputs there, the bottom one there, that's digital I/O. It has the pulse width modulation, so you can hook a little buzzer to that if you wanted, a little MOSFET with a buzzer, and have an audible alarm, or possibly even a speaker for some music. These three are, oh, hit the light button. These three are analog in or digital in out. And then here is an I2C bus with the pull-up resistor, so this works as a master, and that gives you flexibility of adding whatever you want to the thing and using this as more like a full Arduino board. As an Arduino, it uses the Atmega 32U4, so it's fully compatible with the Arduino Leonardo. When you're uploading sketches to it, just set the Leonardo, use the Leonardo setting, and it will work just fine.